right, so the solutions for this worksheet 1 on particle motion. The first part here is talking about the terms that you need to know. Position function, that's just your x of t, your starting point. You have velocity. Remember, that's the derivative of the position function, or it's also called v of t. That's how fast the position is changing in terms of time, and there's direction involved with that. And then finally, acceleration. Remember, acceleration is the second derivative of the position function, or the first derivative of the velocity function, or a lot of times it's denoted as a of t, and that's how fast the velocity is speeding up or slowing down, how fast it's changing. So when they talk about the term initial, when they're talking about initially, they're talking about when time is equal to 0. At the origin means that your position, or x of t, is equal to 0, and at rest means velocity is equal to 0. And then the next one there, if the velocity of the particle is positive, that means it's moving to the right. If the velocity of the particle is negative, it's moving to the left. To find the average velocity in time, you would have to divide the change in the position by the change in time. Instantaneous velocity is velocity at one single instant in time. Instantaneous, they're talking about the derivative. Acceleration of the particle is positive, then the velocity is increasing. If the acceleration of the particle is negative, that means the velocity would be decreasing. In order for the particle to change direction, the velocity must change signs. So go from a positive velocity to a negative velocity, or the other way around. And then this last part, this we might need to look at a little bit here. It says, what's the total distance that the object's going to travel? X of t is its position function. What's the total distance it travels from 0 to 6? So let me just slide this down a little bit here so we have some space. Okay, so we need to figure out the resting points. That's where it's going to change direction. So its resting points is going to be when the velocity is equal to 0. So we need the derivative. And derivative would be t squared minus 2t minus 3. If I set that equal to 0, I'll get t minus 3 and t plus 1. So your time could be 3 seconds or negative 1 second. We said time had to be between 0 and 6. So 3 is our only possible critical value there. It's going to be the point where it changes direction. So we need to see where is the object when it starts, when time is 0. Where is the object after 3 seconds? And then where is the object after the 6 seconds there? So if you plug back into your original equation there, up here, we plug in t is 0, we're going to get 4. So the object starts at 4. If you plug in 3 and simplify, you're going to end up with negative 5. So if I plug 3 up in there, I'll get negative 5. And if you plug in x is 6, you're going to get 22 back in that original function. So I kind of like making these little number lines here. If your starting position is here at 4, the object is moving to negative 5. So it's moving back in this direction. Think of a number line to negative 5. And then that's when time is 3. And then from negative 5, the object is moving to positive 22, which would be way up here. So this was after 3 seconds, and then this was after 6 seconds. So it moved a total distance of 9 units to the left, and then it moved 27 units to the right. So its total distance would be that 9 plus that 27, which is 36. Whatever kind of units these are. So that's the first worksheet.